This is one of my favorite stories, the derivation of the quadratic formula. And the reason is because, probably I mentioned I'm not good at memorizing, and I just keep forgetting the formula. But you don't need to worry about it, because with some elementary algebra knowledge, you can find it easily. Okay, so this is the general form. A, B, C are some real numbers. Let's write that down. And of course, A is not 0, otherwise we don't have a quadratic equation. So what can we do? Well, we just want to solve it. We could solve this easily if these were actual numbers, but there is not much difference. We just have letters. Okay, so what do we know? Well, we know that some number is not 0. Oh, then we can divide by it. Okay, so we can have this. And that is, well, so after dividing by A, I can put this on the other side, and you will see soon why that's a good idea. Okay, so what we have here is, it almost looks like if we had this complete square. Okay, so it's like let's just remind ourselves that x plus some number squared, that's the same as x squared plus 2 times ux plus u squared. Okay, so it would be nice to have this complete square here. We don't have that, but we can sort of aim to get to that form. So I can just say that this is x squared plus 2 times b over 2a x equals, well, negative c over a. This is of course the same, but now this looks more like this. So now I can see that my u in this case will be b over 2a. But of course, this u squared is still missing. But this is an equation, so, well, I can just add them to both sides. Okay, so this is x squared plus 2 times b over 2a x plus b over 2a squared equals negative c over a plus this one again. Okay, so whatever that value is, we just add it to both sides. So there is no problem. And now this is like a complete square. Okay, so this can be written as x plus b over 2 times a squared. And that is the same as negative c over a plus b over 2a squared. Okay, so let's just work on the right side a bit. And so this is of course not changing. I can do the squaring and I can find the common denominator. So if you do that, you will have b squared minus 4ac divided by 4a squared. Okay, that's somewhat familiar. So at this point, there are a couple of ways how we can proceed. We can just take the square root of both sides. So this will be the absolute value of x plus b2a, and this would be the square root of that. But there is another way to think about it. So this is basically, so what's the shape of this one? Well, if you look at it, this is something like, this is, yeah, whatever, let's call it u squared equals some value. Okay, so now we know that, well, v has to be greater than or equal to 0 because it's a square. Okay, so we can safely take the square root, and so I can write this as u squared equals the square root of v squared. Okay, so this might look like a bit funny way to write it, but you will see the point in a moment. Okay, and I'll just turn the page. Because now I can write this whole thing as x plus b over 2a squared. Now I just get the whole thing on this side. Okay, and it is squared. Okay, so why did I do that? Well, again, it's like I take the square root and square it. That's just like having b squared minus 4ac over 4a squared. So that's okay. But now the shape is, if you remember, this looks like u squared minus v squared. Okay, u and v is like, okay, now the different things equals 0. And that is, you know, the iconic identity. So this is u plus v times u minus v. Okay, so I can actually do that. It's like, well, I have to be somewhat careful in writing this down to have enough room. So this is x plus b minus 2a minus the square root of b squared minus 4ac okay, so I have the well, that's u minus v. I just replaced it. The order in this one is multiplied by, so x plus b over 2a plus the square root of, yeah, this thing again. And, well, so where to put this? This whole thing is 0. So whenever I have this, you know, p times q equals 0, it's either p equals 0 or q equals 0. That's a fairly standard way of thinking about it. So that means that you know, I can take this one to be 0, so I can write x, oh, I want to have a different color, it's x plus b over 2a, and it's, well, yeah, it doesn't really matter to have this parenthesis minus the square root of b squared minus 4ac, and I can put the absolute value of 2 times a there, and that equals 0. So now I can conclude that x, am I still in view? Yes, x equals negative b over 2a minus the square root of b squared minus 4ac divided by the absolute value of 2a. Okay, so there is this little trouble about, yeah, that becomes plus. There is a little trouble that we have the absolute value here, but you know, it's the other part is exactly the same, so I basically have plus and minus there, and therefore it doesn't matter whether this is negative or positive. So I can just conclude that x will be minus b plus and minus the square root of b squared minus 4ac divided by 2a, which is the quadratic formula. Okay, so what's the point here? The point is that you know, if you just look at this end result, this is like, well, I find it difficult to remember because it's just a bunch of symbols. On the other hand, it's the whole derivation is not that long, and it's just practicing some basic algebraic operations. You can do it in a different way, and you can derive the formula. But the point is that, well, you do have the power, if you know a little bit of algebra, to actually figure it out yourself. And it's a very good practice to start with the general quadratic equation and try to solve it and try to find the two solutions, and you find the formula for that. And it's like, if you do it, well, yeah, you know, it may not succeed in the first time, but if you do it a couple of times, then the whole process becomes clear, and as a side effect, you will actually remember the formula as well.